Okay, I'm going to be going over a few of the things that I wasn't able to go over last time from the same quiz. Now, the first one was logarithms, and they are way easier than they look. You understand how to raise something to a power. The logarithm is the opposite of that. So you just need to understand what is placed where, right? So for example, this one says y equals log base 6x. Okay, now what this really means, right, is that the base right there, that 6, is what is going to be raised to a power. So if it were log 2, you would really be going, okay, 2 to what power, right? And now the thing that's interesting about this is that it is 6 to the power of y, right? That's how we would rewrite it. So 6 to the y would equal x. So I kind of have this more clearly over here. So if you saw log 6x equals 2, that means this 6 becomes the base, and then the answer is what you would be squaring it as. So 6 squared is 36. So if you saw log 6 36, the answer would basically be what power of 6 would give you 36, and that would be 2, right? So the number down below is the base, and the solution of the log is the power that you raise it to. Now there's one that you're going to be using a little bit that at first doesn't make any sense for time and growth, and it is the natural log, ln. Now you normally don't need to know what it really means, except you need to know that on the calculator, e is the power, right? So the base of natural log is e. Okay, and so you'll see e to the x on your calculator screen. So this is a natural rate of growth. So if you wanted to see like how long it would take to triple your money, okay, so let's say you wanted to get 3 times the money that you had, or 3 times the growth rate, right? Then line natural log, ln, of 3 would tell you the time it would take, okay? So e to the power of x, I didn't quite write this right, I apologize. E to the power of x lets you plug in time and get the rate of growth. The natural log of x, which is the opposite of that, lets you plug in growth and get the time it would take. So if you had your calculator, right, and you said, okay, I want to know how long it would take for this population to increase to 5 times its size, then you would put in line 5. And the answer to that would be the time that it would take. Okay, so your answer is in time. But if you wanted to know, right, okay, what would my population growth be after 2 years or 2 months or whatever it is, depending on the rate, right? Then you put e to that rate. So you would plug in on your calculator e to the x power. And for x, you would plug in the time, let's say 10 years. And then it gives you the growth. Okay, now, in order to solve this problem over here, as you can see, the actual answer to the first part is given down below, 6 to the y, right? So we're rewriting the equation in exponential form. It's just going to be 6 to the y power. And then it asks you to solve these. And so one of the things that I want to show you is how to easily manipulate exponents. Okay, so exponents are easy to manipulate, right? If you have something to a power and you have a negative, okay? So for example, I had 6 to the negative 2 power. That is the same as 1 over, let me write an equal here for you, 1 over 6 squared, which I'm just going to make is 36. Okay, so if you see 6 or whatever to a negative power, you move it below the line of division, and then you just do it. So over here, right, let's go back and look at the first one. 6 to the negative 2. Okay, so that's the same as 1 over 6 squared. So your answer here for x is just 1 over 36. So whenever you see a negative, either below or above the line, you just move the whole thing. And these are independent, okay? So this one would actually be 1 over 6, right, the second one. That's all that is, because it would just be 1 over the power, 1 over 6 there. Okay, so let me give you another example of how to manipulate exponents, because this is kind of important. All right, so let's say you have 2x, I'm going to use the actual superscript this time, 2x to the fourth times 3y to the negative third squared. All of that, okay, hopefully autocorrect. Well, let's just pretend that that divisor is how I want it to be. Okay, all of that over x to the negative 2 let's do 3y, and let's make it squared. And it said simplify this. All right, so the very first thing you need to do is look at what's in parentheses. That's the very first thing you're going to need to do. So you actually have to do everything that's in the parentheses. So that, when we do that middle part, 3 times 3, we square it, is 9, right? That is 3 squared. So what you're really doing is multiplying exponents, right, when you raise them to a power. Okay, so negative 3 to the second power would be negative 6, right? So this is going to turn into 2x, I'm just going to use the caret this time, to the fourth times 9y to what power? To the negative sixth. Okay, so since that one is negative, the y is going to flip down, but the 9 is not. So we're treating everything independently here. We've got a 2, we've got an x to the fourth, we've got a 9, and we've got a y to the negative 6. So we need to actually combine the 9 and the 2, so we multiply them to get 18. Okay, and then we have times x to the fourth, and then we have times y to the negative sixth. So that's going to be the top part. And then at the bottom, right, I'm going to put my stupid line here. At the bottom, we still have the same thing, right? So I'm just going to copy and paste it. X to the negative 2, right, 3y squared. Okay, so now that we have this right here, we need to simplify. So 18, is it divisible by 3? Yes, it is. It becomes 6. So we actually divide 18 by 3. We treat all of these independently. So we get 6 on the top. If there were 18 on the bottom and 3 on the top, then 6 would be on the bottom. So we're just dividing 18 by 3. Then we look and we subtract or move the negative toward the top. Okay, so anytime you're moving across the line, you're actually subtracting the exponent. So x to the fourth, right, we're going to move it toward the bigger one. So 4 is larger than negative 2. So then we would have x to the fourth, and we have to subtract the lower integer, minus negative 2. Okay, so that's going to reverse the sign. So that is going to become, in a minute, x to the sixth. 4 minus negative 2 is x to the sixth. Then we have to move that y down to the bottom, and we're subtracting it as well. Okay, so we're still subtracting that line, and we're getting y squared minus negative 6. Okay, so when we actually do that, when you are multiplying exponents like that, okay, when you're not raising them to a power, you're just adding or subtracting them. Okay, so that means your answer, I'm going to go 4 minus negative 2, so I have 6x, let me get rid of the superscript, that's why I don't mess with it, 6x x to the 6th, all of that, all right, is going to be over y to the 8th. So you want to generally move it to the larger, and you have to consider positive or negative. The positive is the larger. Practice problem here real quickly for this. So when you look at this particular problem here, you've got x to the 3rd, all of that cubed, times x to the negative 2, times 2y to the 5th, all of that squared, over xy to the negative 2. So what you need to do first is the parentheses. And when you're multiplying, right, when you're raising something to a power in that way, you're multiplying the exponents. So the first one there, x to the 3rd power, what you're actually going to get there is going to be x to the 3 times 3, right? So when you look at this, if 3 is raised to a 3rd power, you multiply. Okay, so that's going to be x to the 9th. So we've done the first part. And then I have, right next to that, x to the negative 2. Okay, so I still need to do something with that negative 2. Okay, when you're multiplying two things, right, you're not raising them to a power. It's almost as if, okay, let's say you had two 2's, and then you multiplied it by another 2. Well, that's the same thing as 2 to the 3rd, right? You're multiplying 3 different 2's together. So in this case, you're just adding them. So x to the 9th times x to the negative 2, you add or subtract, basically, based on, if this is negative, you're taking it away. So that's the same thing as x to the 7th. So x to the 9 minus 2 is 7. And then we still have something to do there, right? Because we have the parentheses next to it. So we have to raise 2y to the 5th to the 2nd power, which is going to give us 4. Y to the 5th is 5 times 2. Y to the 10th. Okay, so all of that, right, is going to be over xy to the negative 2. Now, from here, I'm going to subtract toward the larger numbers. In this case, they're all on top. So I'm going to say, okay, this is x to the 1. So then to get rid of this x, I'm going to have to say x to the 7th minus 1, right? So I'd be left with x to the 6th there when I subtract it. And then for y to disappear from the bottom, right, I would be bringing it up and subtracting a negative 2 there to get rid of this. So I'm subtracting when I go across there. So I'd be left with the 12th, right, when you subtract a negative 2. And normally when you write this, you're going to put the integer in the front. So 4x6 y to the 12th would be the answer to that particular problem there. And so, you should probably practice a little bit with this, but just remember, if you're raising to a power, you're multiplying. If you're just multiplying, like x squared times x squared, you're adding. So x squared times x squared would be x to the 4th. X squared times x to the negative 2, right? You're adding them. That would be x to the 0. That would be 1. 1 would be your answer there, right? So you're adding or subtracting when you're multiplying these variables. And then if you're raising them to a power, you're multiplying them. If you move across the line, up or down, right, you're subtracting. Otherwise, if they're on the same side of the line, you're adding them. Very easy to manipulate. So in the next one, I'm going to go over the vertex of a parabola, and then we'll see where else the class is going from there. Hopefully this makes sense. If not, I'd be happy to